welcome everyone. I am Dr. Manoj Kumar Sharma, Associate Professor, ITS College of Pharmacy. This is the lecture number 12 and it is a continuation topic probability part 2. The subject is biostatistics and research methodology. The code is BP801T and the course is Bachelor in Pharmacy and University Dr. APJ Abdul Kalam Technical University. The contents of today's lecture are Poisson probability distribution and normal probability distribution. Poisson distribution: when there is a large number of trials, but a small probability of success, binomial calculation become impractical. So, for discrete variable like number of tablets, Poisson probability distribution is used. Okay. So, when the random variable have more than 2 outcomes, we also use Poisson probability distribution. In Poisson probability distribution, if lambda is the mean number of occurrence of an event per unit interval of time or space, then the probability that it will occur exactly x times is given by probability of x equal to lambda raised to power x e raised to power minus lambda upon factorial x, where E is the Napier constant and its value is 2.7182. So, to calculate the probability in Poisson distribution, we will use this formula for a random variable for different values. To understand this, we take a practice problem on Poisson distribution. It is given that 2% of tablets are defective. Use Poisson distribution to find the probability that a packet of 100 tablets contain, first is no defective tablet and second is one defective tablet. So, in this example, we have total number of tablets 100 and the probability of success for us is 2% of tablet, and we want to find when there is no defective tablet and only one defective tablet. So, to solve this, as in the question, mean number of defective tablets lambda equal to 2% of 100, because total tablets are 100. So, the number of mean number of defective tablet lambda equal to 2% of 100 and it will be equal to 2. So, mean number of defective tablets in this example are 2. Now, for no defective tablet, then random variable x have equal value 0, that means no defective tablets, the x equal to 0, and the probability of this equal p x equal to 0, as the formula is probability of x is lambda raised to power x e raised to power minus lambda upon factorial x. Now, it becomes, as you see also here, the formula lambda raised to power x e raised to power minus lambda upon factorial x, where lambda is the mean and x is the random variable, and here the value of random variable is 0. So, when we put the value of lambda is 2 and x is equal to 0, this becomes like this, and as we know 2 raised to power 0 equal to 1, e that is 2.71 something square into factorial 0, and the value of factorial 0 is 1. So, on solving this, we get the answer 0.135. Now, the second problem is when there is only one defective tablet. When one defective tablet, the random variable have value 1. So, x equal to 1. So, the probability of one defective tablet p x equal to 1 equal to on the using this formula lambda raised to power x e raised to power minus lambda upon x. So, the value of lambda is now 2 and the value x is 1. So, 2 raised to power 1 e raised to power minus 1 upon factorial 1. When we solve it, we get the answer 0.270. So, this is the probability to find the one defective tablet out of 100 tablet. Now, the characteristics of Poisson distribution. Poisson probability distribution is a discrete distribution, because in this we have random variable whose value are discrete. Second, occurrence are statically independent. Third, mean number of occurrence in a unit of time is proportional to the size of unit. If 5 in 1 year or 10 in 2 year, etc. And mean of Poisson probability distribution is NP, lambda equal to NP, where n is the number of trials or observations, p is the probability of success. And standard deviation of Poisson distribution is square root of lambda or square root of mean, and it equal to square root of NP. And be remember, the Poisson probability distribution is always right skewed data, and Poisson distribution is a good approximation to binomial distribution when n is greater than or equal to 20. That means, when number of trials are more than 20, then it have better approximation than binomial distribution, and the probability of success is less than or equal to 0.05. So, when we have more than 2 outcomes in discrete data and probability of success is very small, then we apply Poisson probability distribution. Now, next is normal distribution. Normal distribution, it is a continuous probability distribution, and it has random variable take can any values within a given range, for example, height, weight, marks, etc. Or you can say simply the random variable is continuous in normal probability distribution. So, normal probability distribution is called continuous probability distribution. This normal probability distribution, or in simple way we can say normal distribution, developed by 18th century mathematician and astronomer Carl Gauss. So, it is also called Gaussian distribution. When we draw here, this is the random variable x, and on y axis we have probability density function, on y axis we take probability distribution density function, and on x axis we take random variable. And if we plot a graph for more normal distribution, it looks like this. That means, it is bell shaped in nature. So, for normal probability distribution, if we plot the probability density function curve, we find a bell shaped curve, and there are the some characteristics of this bell shaped curve. This curve, first characteristics of this normal distribution curve, this is symmetric in nature. Second, it is unimodal, that means, this curve have one peak. So, it is unimodal. Second, it is symmetrical about its axis, and at this point mean equal to median equal to mode. So, for normal distribution or normal probability distribution, mean and median and mode are symmetrical, or you can say same. Next characteristics of this, the tails of this normal probability distribution curve never touch the x axis, because if it touch x axis it means random variable have value 0 values, but it is not possible कि कोई random variable हो और उसकी वैल्यू 0 हो, ऐसा कोई हो ही नहीं सकता, ठीक है। तो उसकी प्रोबेबिलिटी 0 नहीं हो सकती किसी भी इवेंट की, अगर इवेंट होगा तो उसकी कुछ ना कुछ प्रोबेबिलिटी होगी। तो सो द दीज टेल्स नेवर टच द एक्स एक्सिस। सेकंड, the area under the curve, used to calculate the probability of the data, and the maximum area of the curve is equal to 1. As we know, the maximum probability of an event is 1. So, the maximum probability is 1 and 0.5 area lie on this side and 0.5 area lie on this side. So, and maximum area is 1. Next, the mean or mu and SDR, area under the curve tells the probability and the total area in the curve is 1 or 100%, mean represented by mu and standard deviation by sigma. When we define the normal distribution, we consider only two parameters, mean and standard deviation, and there are three cases: same mean, but it have different standard deviation; second, it have same standard deviation, but means are different; and third is mean and standard deviation both are different. So, these are the three cases to define the normal distribution, and the area under the curve, as you see here, this is the mean mu, and now mu plus 1 sigma, mu plus 2 sigma, mu plus 3 sigma, where sigma is the standard deviation, mu is the mean, and for this side mu minus 1 sigma, mu minus 2 sigma and mu minus 3 sigma, and the area under the curve follow 68, 95, 99.7 rule. It means the area, the curve between mu plus 1 sigma and mu minus 1 sigma is approximately 68.27%. That means, the area under the curve between mean plus minus 1 standard deviation of the data cover the 68.27% data, or and mu plus 2 sigma and mu minus 2 sigma, that means mean minus twice of standard deviation covers 95.45% area, and the third is mu minus 3 sigma and mu plus 3 sigma, or simply you can say mean plus minus thrice of standard deviation is the show the 99.73% area of the curve. So, it follow 68, 95, 99.7 rule. Mu plus minus 1 sigma have 68.27% area approx. Second, mean plus minus twice of standard deviation cover 95.45% area, and mean plus minus thrice of standard deviation covers 99.73% of the data. This is the, I have already told you the mean, I again repeat, mean plus minus 1 standard deviation covers approx 68% area under the curve. The mean plus minus twice of standard deviation covers approx 95% of the area under the curve, and the mean plus minus thrice of standard deviation covers 99.7% of the area under the curve. Now, as we know, a random, we have different types of random variables, and these random variable have different means and different standard deviation. So, for different variable they have different standard deviation and different means, we cannot calculate easily the area for calculate probability. So, to do this we transform this x axis into a z axis, and this z axis equal to x minus mu upon sigma. We convert x axis into z axis to standardize this. To standardize this, and now it becomes z. So, z equal to x minus mu upon sigma, where z is the number of standard derivatives from x to mean, and it is also called z score, and x is the value of random variable. So, as we know here for x axis at this point we have x equal to mu. The mean is for this point, we have random variable x equal to mu. So, at this point z convert into mu minus mu upon sigma, this will be equal to 0. So, at this point where z is 0. Why? For next this point at this point and in this point x is mu plus sigma, because this at for x axis, if we show here x axis, this is mu plus sigma, this is mu plus 2 sigma, here mu minus sigma, here I write here mu minus 2 sigma, and for third point mu minus 3 sigma, and here is we write here mu minus plus 3 standard deviation. This is the x axis, and now we transforming it into z axis. So, at this point the value of random variable is mu, and we get z mu minus mu upon sigma, this will be equal to 0. So, z equal to 0 at this point. For second case, in second case x is equal to mu plus sigma. So, z equal to mu plus sigma minus mu upon standard deviation, and this will come as mu will cancel out sigma upon sigma, and this will be equal to 1. So, value of z is here 1, and similarly we calculate z for mu minus 1 standard deviation, and it will be minus 1. And with the for third case, when x is mu minus 2 sigma plus 2 sigma, when we put mu plus 2 sigma in this formula, you get mu plus 2 sigma minus mu upon some sigma, mu will be cancel out, and this will be equal to 2 sigma upon sigma, and it will becomes 2. So, this point is 2 and this is minus 2. Similarly, the third is z equal to 3 and this is minus 3. So, we convert z axis into x axis into z axis to standardize the results. Now, this normal probability distribution curve is known as standard normal probability distribution curve, or simply you can say standard distribution. And the area under the same in standard curve from 0 to 1 is 0.34 and 0.34 this side, that is 0.68. This is 0.68 approx, and this is 95 approx, and this is from this 99.7%, and this is called, this area is called tail area, and if this is for 2, this is 95%, then it becomes 5% and half of 5% here and half of 5% is here. So, the tail region is 0.25 and 0.25 for this. This is the tail area, and this is also called rejection area. Practice problem for normal probability distribution. The mean weight of a tablet is 147 milligram with standard deviation of 3 centimeter. What is the problem of weight being greater than 152 milligram? In our problem, we have the mean weight of tablets is 147 milligram for a batch. We have some tablets in a batch, and the mean weight of these tablets are 147 milligram, and the standard deviation of the weight of the tablets is 3. Then what is the probability of weight being greater than 152 milligram? We want to find standard deviation is 3 milligram and weight being greater than 152 milligram. So, to find the probability, we put first we have mean x bar equal to 152 milligram, random variable mu, mean is 147 milligram and standard deviation is 3. Now, z equal to 152, as we know the formula of z is x minus mu upon standard deviation. So, this is the random variable, this is 152 milligram, mu mean is 147 milligram and standard deviation is 3. On solving this, we get 5 upon 3 and it equal to 1.66, and at 5% of level, at 5% of level, the value of z for when z equal to 1.67, if it is 0, then it will come here, and for z from the we have some tables to find the area z score table, and from the z score table we find that the area for z equal to 1.67 is 0.9524. This is the area for z equal to 1.67, but here in this question we want to find the probability when weight being greater than 152 milligram, but this z shows when weight is 152 milligram. When weight is for random variable 152 gram, the area of the curve is this, and we want to find the probability of weight greater than 152 milligram. So, for this we need this area, which value z is 1.67 more than z equal to 1.67. So, we need this area to find the probability more than 152 milligram, because I again explain you, if value of Z is 1.67, the area under the curve is 0.9524 और हमें जो फाइंड करना है, हमें फाइंड करना है उसकी प्रोबेबिलिटी जब 152 मिलीग्राम से ज़्यादा हो, तो दैट मीन्स हमें वो एरिया चाहिए जिसके लिए Z की वैल्यू 1.67 से ज़्यादा हो, तो हमें ये एरिया चाहिए. अब वी नो द टोटल एरिया इज इक्वल टू 1, सो वी सब्ट्रैक्ट दिस 1 माइनस 0.9524 and it will be equal to 4.75%. So, this is the probability that the tablet have weight more than 152 milligram. This is the answer. I again so we today in this lecture we read normal probability distribution and Poisson distribution. So, Poisson distribution is discrete distribution and normal probability distribution is continuous probability distribution, and we calculate the normal distribution probability with the help of this graph, this curve, and the values for different value of Z, we have a Z score table from which we calculate the area under the curve. Okay, thank you.